All right, so this is on Standard 9A, how to calculate a molar mass. A molar mass is the mass of that substance if you had a mole of it. You're going to go to your periodic table. On your periodic table, you have the atomic mass. So if you were looking at carbon, for example, the oxidation states are up in the right-hand corner, and the top left-hand corner is the atomic mass. And I think for carbon, it's 12.011, something along those lines. Generally, for Regents Chemistry, you can round that to the nearest whole number unless you're told otherwise. So the mass of 1 mole of carbon would be 12 grams per mole. Molar mass is called molar mass. It's also usually referred to as gram formula mass. Okay, or formula mass or molecular mass, and there's a lot of different words that we use for it. But gram formula mass is probably, or formula mass is the one that I see the most. It's the mass of the formula in grams. So if we have something simple-ish like carbon dioxide, CO2, and I wanted to know the molar mass of that, I would add up the molar masses of all of the parts that make it up. So I have 1 carbon atom. You can see that because it has no subscript, so that would indicate there's only 1 of it. So carbon weighs 12. I would saw that on my periodic table, so I would do 12 times 1. And then I have 2 oxygen atoms. So I could add 2 16s, because oxygen, according to my periodic table, weighs 16. Or I could just do 16 and how many of them I have, which is 2. When you do this in your calculator, you should get 44. And the units are grams per mole. So a mole of carbon dioxide would weigh 44 grams. Now, sometimes it's a little confusing when you have parentheses. Let's do magnesium hydroxide. So that 2 is outside the parentheses, right? That means you have 2 hydroxides. So you have 2 of everything inside. You have 2 O's and you have 2 H's. Any subscripts on the inside you would multiply by. So in this case, I've got magnesium, I would round to 24, and I have 1 of them. I have, what I like to do, because I am always afraid I'm not going to distribute that 2, I figure out what hydroxide weighs, which is 16 plus 1. Hydrogen weighs 1 and oxygen weighs 16, but I have 2 of them, so I'm going to take that whole quantity times 2. All right. Now, what else can we see? Sometimes you'll see things like, let's see, let's do this one. Ca3PO42. This is calcium phosphate, okay? We have calcium, which weighs 40, and 3 of them. And then, see that 2 outside of there? There's not 6 oxygens, there's 8, because it's multiplication. So I have 2 phosphorus, and I have 8 oxygens. So again, I like to figure out what the mass of the inside is first, which is 31 for phosphorus and 4 times 16 for oxygen. And then I'm going to multiply that whole thing by 2. That should be an X, a multiply sign. Okay, and then when I put that in my calculator, I get 310. The last thing we need to talk about for molar mass is hydrated crystals. Hydrated crystals are only confusing because that dot that I'm going to try to draw here, to you in math means multiply, but to me in science it means hydrated crystal. So this is just something that has water as part of its crystal structure. So for me it means plus. Okay, so I have copper sulfate. Okay, so I'm going to add up the copper, the sulfur, and 4 oxygens, and I get 160. And I'm going to add that to 5 water. So that 5 in front is kind of like it's in parentheses, even though they don't draw the parentheses. It's going to apply to everything after it. So I know that water weighs 18 because hydrogen weighs 1. There's 2 of them, and oxygen weighs 16. So a hydrated crystal, that dot, just means plus. So you're going to add all the copper and the sulfur and the oxygens to the mass of 5 waters. So you should get about 250 for that one.